Hey everyone, so yeah, I'm Wilmer. I've been at Lightning Labs for a little over a year. And yeah, today we'll be talking about the latest major release of LND, 0.7. So we're just going to start with a brief overview. We've had 418 commits since the last release. That was a minor release, 0.6.1. We've had 15 external contributors since then. Yeah, so this release includes 2 database migrations, one related to the wallet and another related to payments, which I'll get into later. And really the main themes of this release are faster initial sync times, enhanced fee control, improved payment tracking, stochastic pathfinding, and watchtowers. So yeah, let's get into it. So compatibility with Bitcoin D. For some users, some users might have experienced this. Bitcoin D had a release of 0.18, and there were some changes that basically affected us. And so with 0.7, we're fully compatible with Bitcoin D versions up to 0.18. So what changed? Basically, we use the send raw transaction, RPC, to broadcast any transaction within LND. So it's basically just processing the transaction from LND to Bitcoin D. And so, yeah, they modified the error string. I know, we rely on error strings. But yeah, they basically modified it. They changed a single letter from lowercase to uppercase. And yeah. So how did this affect LND exactly? So obviously we were trying to parse for this like substring of the full error string. And obviously, because it changed, it was no longer successful. So the error string was related to broadcasting a transaction that already confirmed. So with the send raw transaction RPC, if you broadcast a transaction that has already confirmed, then it'll return an RPC error like, oh, this transaction is already in the chain. And so this basically resulted in successful broadcast attempts within LND being interpreted as unsuccessful, right? Because we weren't catching that error and not returning an error from the API level. And so yeah, fortunately there weren't really any major consequences because LND has been sort of designed with ignoring these errors, to sort of not rely on these errors when broadcasting transactions other than double spends. And this is due to Neutrino. So Neutrino is a light client for those of you who are not aware. And obviously, as a light client, you can't really, you're constrained in terms of resources and just like things you can do. You obviously don't have the full chain, and so you can't really validate things. And so when you broadcast a transaction with Neutrino, you don't really know if it confirmed or not, right? Like there's no sort of response that you can get from a node on the network that you can trust. And so, we had to sort of design this with that in mind. So, yeah, nothing really happened. We are fully compatible with 0.18 now, so everything good. Moving on. So initial sync improvements. I don't know how many of you start a new node with LND and Bitcoin D. But basically, the wallet stores all block hashes of the chain, and this is in order to recover from very deep reorgs. For example, during the initial phase of development for LND, it was on testnet, and at that time there were just huge block storms of like thousands of blocks coming in, and it would cause massive reorgs. And so, just sort of as like a intermediate fix, we decided to store all block hashes. Obviously, now with the chain growing, this isn't really ideal, and it was taking about 30 minutes to just spin up a new LND node backed by Bitcoin D. And this was mainly because you basically start from the genesis height, which is 0, obviously, up to the tip of the chain, and you basically call get block hash for height and get block header. And so yeah, it's basically 2 RPC calls per height. So we have like 5,000 blocks in the mainnet chain, and so yeah, that can obviously blow up. And with Bitcoin D specifically, basically a new HTTP connection or HTTP request is being sent every single time. So obviously, very, very inefficient. So yeah, we move towards this model where we only store the 10,000, the latest 10,000 block hashes of the chain. This can get tricky. For example, if you're like restoring a wallet, there's really no way of knowing like where you start. But thankfully we have AZ, which is our CipherC format, and it does encode the birthday there. So basically, the birthday is encoded as a timestamp. So what we do is we map the timestamp to a block on the chain, just performing a simple binary search. And so yeah, we can get like the initial like relevant block where we can actually like start scanning for things in log_n, which is pretty cool. And so yeah, doing this basically resulted in spinning up a new node, taking from 30 minutes to 1 to 2 minutes, which is pretty cool. And obviously the same results happen for wallet restores, though obviously this is a longer process because you have to start scanning blocks from that point, and that does take time. We will be working on this in the future once filter support has sort of improved in Bitcoin-D. But basically, we'll be able to use the compact filters from BIP 157 to 158 and speed up this process so that we don't have to like scan blocks where we, that are not actually relevant. So yeah, that would be another nice improvement there. And yeah, as a side benefit, this also allows nodes to be started while the backend is syncing. So if you started a new Bitcoin-D alongside with your new LND, you can just sort of start both, and LND will handle this gracefully now. Cool. So enhanced fee control is something that I worked on, and so basically, we've been having some high fee periods lately, and we sort of want to give a little more control to users within LND. So with this release, we've added some RPCs to sort of address this. They're located within the WalletKit subserver. Subserver is sort of like this thing that we've been doing, basically just like breaking down the main RPC interface into different components that are all related. So obviously within WalletKit, you have bumping fees, estimating fees, creating transactions, listing your UTXOs, all things like that. And we have a couple more other subservers. You can check out the documentation in LND or other talks. I know Connor talked about them at the last talk. But yeah, basically we have this new bump fee RPC. It has a corresponding LNCLI wallet bump fee command. And so yeah, basically it requires an out point and a fee preference. Fee preference can be expressed as a fixed fee rate or a confirmation target. Confirmation target is just like a delta of when you want the thing to confirm by. And it supports replace by fee and child pays for parent. So replace by fee is just like this, for those of you who are not aware, it's just like this mempool policy that allows you to replace an existing unconfirmed transaction within the mempool with a higher fee transaction. There are some certain limitation, rules there that you can't like replace it if the transaction has too many descendants and things like that. We don't need to get into, but and child pays for parent is basically you can think of a transaction having a low fee and you want to bump it. So what you do is you spend an output within that transaction, and in that spending transaction, you're going to provide a higher fee rate, and that basically, miners basically interpret this package of two transactions as one, and they'll, because they do that, they can sort of take the overall sum of the fee rates and use that as a basis of whether they want to mine the transaction package or not. So yeah, obviously there aren't like ways to specify which one to do. So it all depends on the output that you're providing. So for a child pays for parent, the out point needs to be a change output within a transaction, and it needs to be under the control of the wallet, which allows us to actually spend it. And for replace by fee, there is this transaction batching engine that is sort of in development within LND that I haven't really mentioned, but basically, if the out point is within this batching engine, you can perform an RBF for free. So you can think of the case where maybe you have a funding transaction with a 1 sat per vbyte fee, and maybe let's say there's a spike in fees, and now you need like a 10 sat per byte, and so you would do, for example, a CPFP because your funding transaction has a change output, and now and you provide a sufficiently high fee rate for that. But now let's say fees rise again. Well, obviously you don't want to perform another CPFP because you're just like creating unnecessary transactions. So in that case, the batching engine will recognize this and perform an RBF. And so you're replacing the child transaction in this case. Obviously the parent is the lower fee transaction, and the child is the higher fee. So due to this sort of going through LND's transaction batching engine, it's basically asynchronous because we're batching. We sort of have like a window where we wait for more requests to come in. So we can't really give a response immediately, and so there needs to be a way of tracking the progress of this. And so we do that through this pending sweeps RPC, which basically just like dumps the in-memory state of the batching engine through RPC. So that's all it's doing. On top of that, we also get discoverability of inputs that LND is attempting to sweep. So for example, if a channel is force closed and you need to sweep the output back to your wallet, it would be shown here, and you would get details on like what the outpoint is, what fee rate you're trying to use, the type of the output, things like that. There is one small constraint with this, with the bump fee RPC, unfortunately, and this is sort of by choice. We don't do any validation checks on the new fee that you're providing, along with the bump request, to determine if the high fee rate is actually sufficient for the request to be deemed successful. And the reason why we don't do this is mainly because of neutrino. As you can probably already tell, there's like this pattern where we sort of have to design things with neutrino in mind, just because of the different things we have to deal with there. But basically, since neutrino doesn't really like have a mempool, it can't like verify the it can't do these validation checks required to determine if a fee rate is high enough, and so we kind of just skip that and delegate that to the user. So moving on to payment tracking, this has sort of been an issue for a bit, and so basically, as long as LND was online, everything was fine. But if you happen to make a payment and you restart, if you happen to make a payment and you restart after that and before acknowledging that it completed, then the database state would sort of be inconsistent, and your payment wouldn't really be marked as complete if it did complete once you came back online. And so this was an issue for us, for example, in Lightning Loop, where we sort of needed to rely on this actually being correct. And several other applications that build on top of LND, I mean, it's just sort of like a nice consistency guarantee to have. Another main thing, you weren't really able to track the status of a payment. Another thing that is definitely useful for higher level applications built on LND. We basically just address this by persisting all payment attempts to disk. Sounds very simple, but we actually went through like this whole saga of like 3 months just trying to come up with the best design. It was slated to land in the 0.6 release, and it got pushed back to 0.7. Now that we persist these to disk, we can obviously start tracking these after restarts. And so now payments have a state, which is just like an enum. A payment can be in flight, which means that it has been dispatched, but you haven't received a response for it yet. It can be failed. Obviously, you received a failure for the payment. And succeeded, obviously the payment succeeded. And these are all Lightning payments, of course. And so now, because we are persisting the payments to disk, we have an existing list payments RPC, which just shows completed payments, because that was the only thing it had access to. But now there's a flag that will enable you to get in-flight payments and failed payments. So just something to note, if you happen to like probe the network a lot, these will start showing if you include that flag. Moving on, so now that we have this new information persisted to disk, what can we do with it? So we went ahead and implemented some RPCs to sort of address the shortcomings here. And so we have 2 new RPCs as part of the router subserver, another subserver that we have. We have track payment. You basically just provide it with the hash of the payment, and it allows you to get the status of a payment. You can do it at any time, but obviously it's very helpful after restarts. If your node went down and you want to just know what the status of a payment is. And then we have a new send payment. So this has an explicit payment timeout and fee limit selection. These were previously, we previously had a default for these, and we have a send payment RPC as part of the main RPC server. But to not sort of break compatibility with users, we decided to include this in the router subserver instead, where we can sort of be a little more experimental and play around with things more. So in this case, these things are made explicit now, just so that sort of users are aware of the choices that they're making and the consequences that they will have. And so, similar to track payment, if you call send payment, it will return the current payment status if there is one. And it also additionally attempts to send the payment again if it failed. So that's obviously very useful if you want to resume a failed payment after a restart, rather than having 2 RPCs. I mean, rather than having to do track payment and then send payment, you could just do send payment in one. And so, we also extended send payment to return some additional failures that weren't in the previous API. And so these failures are basically just a timeout failure or a no route failure. Timeout, obviously, there are, the payment timeout was reached and there are more routes available to try, but because the timeout constraint is there, we should proceed. And no route, we exhausted all the routes available, and so we can't really move forward. We plan to extend these in our next minor release with a couple more failures, like incorrect payment details, things like that, etc. But yeah, so if you were building on LND, this would basically be your payment flow before ODAT7, of course. So you would send the payment, you would restart, and at this point, because the database state wasn't really consistent after restarts, well, what can I do? How can I track the payment, right? There's no track payment before ODAT7. There aren't really many options, so the only option really was to continuously retry the payment until it was no longer in flight. And how do you know it's in flight? Well, you have to do string matching, and you basically just have to run this in a loop until it was no longer in flight, which is just kind of annoying. And then if the payment was successful, then it may not be shown as completed in the RPC interface, which is kind of annoying. And so, with ODAT7 now, going through the payment flow again, send the payment, you restart, but now we have track payment and the new send payment RPC. So, if you just want to know the status, you can do track payment. If you actually want to try the payment again, then you can, use the new send payment. And if it completes, bag secured.
Ah.
Why do you restart?
Sorry?
Is that unexpected restarts? Or?
Yeah, or just a mobile client where you just close the app and that's interpreted as a restart. Yeah, but also for just consistency. Cool. So yeah, that's it. So moving on, we have send to route. So for those of you who are familiar, send to route, it basically just allows you to send an HTOC across a given route. Unfortunately, if the route that you provided failed for whatever reason, it wasn't really, the API wasn't really being helpful in terms of the errors that it was returning. So again, this send to route is part of the main RPC, but because we don't want to break that, we added a new send to route RPC to the subserver. So the same router subserver. And so this is a synchronous RPC, which is the same as the current one. But we might move to a model in the future where this is asynchronous and you just kind of have a stream where you can provide it with routes at any given point and it'll immediately return a result for that. But yeah, it only allows a single route compared to the existing one where you could provide multiple routes. similar to query routes. My name is kind of weird because it only takes one route, but whatever. But yeah, so what we've included in these improved failures is basically the exact, we provided a failure code, which is just an enum, with the exact reason as to why the payment failed. And we sort of map these to exactly what nodes send at the protocol level. So some of you might have seen this. If you try a payment, you might see like fee insufficient or temporary channel failure or things like that, right? If you're probing, you might see unknown payment hash, things like that. And just sort of exposing the errors are definitely helpful for users. They know exactly what went wrong with their route. And so along with that, we also provide the source of failure. So this is just like where the failure is coming from, like at which specific hop of the route. And with these two things, you can sort of build your own reputation management system. We kind of have one within LND already. We call it mission control. And it sort of, I'll get into it later, but it sort of tries to learn from the previous attempts. Yeah. So yeah, this is related to mission control. So stochastic pathfinding. Pathfinding before was not very good, I must say. It relied on a list of on blacklisted nodes and edges to prevent like trying the same routes. But unfortunately, this blacklist would be cleared like every 5 seconds. And so, if your payment obviously takes longer than that, this isn't very useful because you could get stuck trying the same routes over and over again. And also another problem with this, concurrent in-flight payments did not share state. So if you were making 2 payments at the same time, they wouldn't be able to share state between them. Just like I tried this route, but the second payment is trying the same route, knowing that it failed for the first payment, right? So we decided to address this in 0.7, and we did so by coming up with a new pathfinding system based on probabilities. And so, we do something similar to active learning-based approaches in machine learning. We no longer rely on these blacklisted nodes and edges, which is nice. And so routes are now also compared by their success probability. So routes are compared by this, but also before that, they're compared by time lock, by their total time lock, which is just like how long the payment can actually take in terms of blocks and in terms of fees. So there are definitely trade-offs to be made there. Maybe you want a longer route, maybe you want a cheaper payment. But yeah, so how does this new pathfinding system work? Well, each channel is basically assigned like a default probability. And this, I believe, is configurable at the moment, if I'm not mistaken. And obviously the probabilities range from 0 to 1. Right now this is set to 0.95, I believe. But yeah, obviously probability is reduced as payment attempts failed. And we're only reducing the probability of the source of the failure of the route, right? So we definitely don't want to affect the probability of the whole route. We just want to identify the source and reduce their probability. And in contrast, we also sort of have an exponential decay back to the default probability. So this allows those routes to be tried, or those edges or nodes to be tried at a later time, to see if maybe they've improved, and if not, obviously their probability will be reduced again. So yeah, this is obviously something very cool, and with this now we're also able to address that third bullet point there, where we actually now do store, we do share state between concurrent in-flight payments. So definitely useful there. And so yeah, to sort of give a little more visibility into what is exactly going on with mission control, we added a new RPC to sort of get the probability state of all the channels in the graph. And so you can do this with this query MC RPC. There's also a corresponding LNTLI command there. But yeah, so because of this, now we actually, while testing this, we realized that we were within the previous model, we weren't really exploring routes very well. We just sort of kind of kept trying the same routes over and over. But with this now, since we'll skip channels rather, sorry, that have low probabilities, we can actually explore the graph even further and find just like crazy routes. I know that while we found a like 9-hop route, it's 9-hop route at some point with like one or like
It was 0 feet.
yeah 0 feet exactly. So it's just like
I'll take that.
and so one thing here is that right now this state is not persistent. So if you restart, obviously you won't have that same state, and everything will sort of go back to the default. We do intend to address this because obviously for mobile clients this isn't very helpful. You definitely want to maintain that data as you make more payment attempts. Cool. So Watchtowers, definitely a big thing for the release. Shout outs to Connor. So funds are safer. So for those of you who are not familiar, Watchtowers, they basically act as vigilance for nodes on the network that have been offline for an extended period of time. What do? They observe the chain for dishonest behavior from their channel counterparties, and they do this in a privacy-preserving manner where personally identifiable information only really gets revealed in the event of a breach. So a breach is considered dishonest behavior from your channel counterparty, and so this is definitely something helpful for even mobile clients. Maybe you go on vacation, you can sort of outsource this vigilance to a third party running a Watchtower, and they can sort of do this for you. Sorry. There is a sort of sense of trust, but you can also just sort of delegate this to multiple parties. And so as well, there is an ability for the Watchtowers to receive a compensation for this, right? There has to be like an incentivization for them to actually do this, and so that's how that's done. Currently, right now, we don't have rewards at the moment. We sort of just wanted to roll them out without that, just to get more testing going on. But this will be done in a future release. So yeah, that's what altruist means. Just if a Watchtower does actually detect a breach and punish the counterparty, they won't get anything at the moment. I think. Are we allowed to take questions now or for later?
Yeah, go for it.
Okay, yeah, go for it.
Is the protocol design public and discussed on GitHub, or is something that you guys are designing privately?
I don't think there has been a formal spec or like bulk kind of thing yet. Not sure what the progress is on that.
It's kind of discussed in the mailing list loosely, kind of like a high level in terms of what's going to design. Like if you look at the code, it's pretty well commented, and the LPR doesn't have a good bit of detail. But we're actually working on kind of like a more formal specification of the implementation to use themselves. But like, if you look at the code, it's pretty like well documented. You kind of like at the high level of it, including mostly the messages itself, and also kind of like some mailing list posts too. But that's coming up in the future.
Cool. I think someone else had any questions.
Tag on GitHub for Watchtower and go through this with the hours, which has a lot of discussion on it.
Oh yeah. So if you just go on GitHub on the LND repo, pull requests, you can like filter by tag and click on the Watchtower tag. Yes.
What's the exponential decay rate in the route pathfinding?
I am not sure.
So it's configurable. I think default is 1 hour, but you can go to like 6 to 12 hours.
So 1 hour, is that like a 50%?
Yes. Basically, this. Yes, it's gonna like starts goes in half. Towards 1 hour. So after 1 hour, it's gonna be back to the original version. So like the A priority, initial A priority.
Cool. And so these Watchtowers are available right now as a subsystem of LND. So you do have to sort of run them alongside an LND instance. Obviously, you wouldn't want to run one yourself alongside with your own LND, because then, if you've gone offline, then your Watchtower is not going to be like online either, right? So it can't work. But yeah, we do plan to have the Watchtower available as its own binary in a future release as well. And so we also created this Watchtower subserver following the other ones, where you can sort of interact with the Watchtower and get details about it, maybe change configuration settings and things like that. Right now at the moment, that is only it only exposes basic information like what the Watchtower pub key is and what addresses it's listening on. But yeah, I have a demo. I wasn't able to fully get through it. I think I might be able to do it later. But yeah, that was it. Upgrade today.
Any other questions?
But then we also have another version.
That's right.
Oh, yeah. Sorry.
Yeah.
Any more questions for Wilmer?
Actually, so earlier you said that you cannot scan with Neutrino whether a transaction had got confirmed, if I understood you correctly. But isn't that one of the advantages of Neutrino, that you can just get the client-side block filter and look whether there is something that pertains to you? So with Neutrino, wouldn't you be able to, especially while you're waiting for a channel to confirm, to get the block filters, check whether the channel has been created?
Yeah. We don't do that at the moment, but that's definitely on the roadmap. Right. In terms of broadcasting transactions, I was more just referring to maybe, let's say you didn't provide a high enough fee on the transaction. You can't really trust the error that you're getting back from the peer that responded to you. So that's more what I was referring to.
And you don't have the mempool.
Yeah, and you don't have the mempool. Yeah, I mean, you can listen, for like mempool imps or mempool messages, but that's just like not very ideal. Sort of defeats the purpose of being a light client. Yes.
You mentioned in the presentation that there's no labels for child-based parent or for RDF. It's like really defined by how you input the values and stuff.
Yes.
I was wondering if you can talk through how come you guys decided not to put labels on it and just decided to just base it on whatever the input is.
Yeah, it's definitely something we considered. We kind of just wanted to throw that out there all under one single RPC just to see maybe if we got any feedback from users. But definitely if users find it helpful to have it as two separate ones, then it's definitely something we can consider. Maybe over here.
So I saw Cosmos recently started doing this, but they created an LTS version of their Cosmos SDK, kind of like how some Linux distributions do that, where they freeze the RPC specs for 6 months, something like that. Have you guys considered anything like that, or is that anything you guys plan to pull?
Not that I'm aware of. We definitely have a lot of changes in the RPC layer, but I feel like it's more sort of just LND is still somewhat new. We're still sort of trying to figure out what the best practices are, how to best design these APIs. So maybe once we have some more experience with that, we can definitely start moving towards that. Yeah.
I'm just curious, is there any way to establish a channel faster, like within seconds, rather than another counterparty to say agree on that?
Sorry, I couldn't really hear you.
Is there any way to establish the channel when you establish a channel?
Mm-hmm.
Is there any way to establish it in the fastest way?
In a faster way?
Yeah.
Well, I mean, the channel needs to confirm on chain and have sufficient a sufficient number of confirmations so that if a rework happens, it doesn't get affected. So really, that all depends on just how fast blocks are coming in.
But I'll address this in my talk.
Oh, okay. Sweet. Yes, Mark.
You mentioned that you can use both RBF and CPFP. Do you have the capability to CPFP bump a channel?
Yeah. So you can actually do that today with this. Yeah. So you would obviously your funding transaction needs to have a changed output, and if it does, you can provide that output as part of the RPC, and provide a high enough fee rate so that when the miners consider the whole transaction package, it's enough. Yeah.
All right, let's move on to Val.